Assalamualaikum warahmatullahi wabarakatuh and welcome to our presentation. So today our group will be presenting about chapter 4 radiation physics with the subtopic of properties of ionizing radiation. So our group member are Aqilah Afiah binti Anuar, Nadhirah binti Hamat, Liyana Amnani binti Mustafa Kamal and Haifa Wahida binti Muhammad Noor.
Introduction of the radiation physics. Radiation is the energy that comes from a source and travels through space at the speed of light. In 1895, Wilhelm Röntgen, German scientist, was discovered X-rays, which is one of the electromagnetic radiation that used in medical imaging nowadays. A few years later, Marie and Pierre Curie, which are French scientists, was found radioactive radium. There are many types of radiation that are indicated in the electromagnetic spectrum. So, what is electromagnetic spectrum? Electromagnetic spectrum is the range of frequencies or wavelength over electromagnetic radiation extends. Electromagnetic spectrum are traveled in the wave form. As we can see in the diagram shows, from the left to the right, which from radio wave until gamma rays, the waveform or wave flow are represent the wavelength. From the left to the right, it shows radio wave has the longest wavelength, while the gamma rays has the shortest wavelength. In this electromagnetic spectrum, it means the shortest wavelength has the highest frequency, while the longest wavelength has the lowest frequency.
There are two types of radiation, which are ionizing radiation and non-ionizing radiation. Firstly, ionizing radiation was classified that have wavelength shorter than 300 nanometer, high frequency and higher energy. Meanwhile, non-ionizing radiation is longer wavelength than 100 nanometer, lower frequency and lower energy. Next, types of ionizing radiation are consist X-ray and gamma rays that have higher frequency. Meanwhile, non-ionizing radiation are ultraviolet, infrared, microwave, radio wave, and visible light that has lower frequency radiation. Lastly, ionizing radiation have three particles like alpha particles, beta particles, and neutron. Meanwhile, non-ionizing radiation exposure associated with ultrasound imaging that capture in real time. They can show movement of the body internal organ as well as blood flowing through the blood vessel.
So next I will be presenting about ionizing radiation. Ionization occurs when an electron in the inner orbit of an atom receives sufficient energy to escape from the influence of the nucleus. And this will cause the formation of a positive ion and negative ion. And as a result of ionization, characteristic radiation is emitted when an electron from an outer shell falls in to take the place of the electron that was ejected. Next, ionizing radiations cause ionization when they pass through matter. Examples of ionizing radiations are alpha and beta particles, gamma rays, and also X-rays. So alpha and beta particles and gamma rays are emitted spontaneously from the nuclei of unstable atoms during radioactive disintegration, which is the radioactive decay. In radioactive materials, radiation is emitted continuously in a regulated manner and there is no way of stopping it. It cannot be switched off. So it shows that when radiation occurs, it cannot be stopped and switched off. So the example of ionizing radiation is X-rays. So what is X-rays? X-rays are produced by the sudden deceleration of the electron in the strong field of the target nucleus. X-rays machines emit radiation only when the machine is energized. So when the high voltage is disconnected, no X-rays are emitted. So X-ray is an electromagnetic energy that is originate from the electron cloud of an atom, and this is generally caused by energy changes in an electron, which moves from a higher energy level to a lower energy level, causing the excess energy to be released. X-rays are similar to gamma rays, however, the main difference is the way they are produced. X-rays are produced by electrons external to the nucleus. Other
There are three properties of radiation, such as alpha particle, beta particles, and gamma rays. First one, alpha rays. Alpha rays are the positively charged particles and mass 4 times of proton. Alpha particle is a highly active and energetic helium atom that contains 2 neutrons and protons. These particles have the minimum penetration power and highest ionization power but can be stopped by a paper or a skin. They can cause serious damage if get into the body due to their high ionization power. They are capable of ionizing numerous atoms by a short distance. It is due to the fact that the radioactive substances that release alpha particles are required to be handled after wearing rubber gloves. Secondly, beta particles. Beta particles are extremely energetic electrons, but they are called beta particles to identify that are liberated from the inner nucleus. They negligible mass and carry the negative charge. A neutron in the nucleus split into a proton and an electron of the emission of beta particles. Hence, it is the electron that is emitted by the nucleus at a rapid pace. Beta particles have higher penetration power when compared to alpha particles and can travel through the skin with ease. Beta particles can be dangerous and any contact with the body must be avoided through their ionization power is low. Lastly, gamma ray. Gamma rays is the wave arising from the high frequency end of the electromagnetic spectrum that has no mass. They hold the highest power of penetration but very poor at ionization and very difficult to resist them from entering the body. The gamma rays carry a large amount of energy and can also travel via thick concentric and thin lead. They are less dangerous to life.
Next, properties of ionizing radiation which have alpha particles, beta particles, gamma rays, X-rays, and neutron beams. For the alpha particles, it have 2 protons plus 2 neutrons. It is same as helium nuclei, and alpha particles charge is 2 positive. Alpha particles have high ionization density. Next, beta particles made of electrons or positrons. It charge particles negative or positive. Beta particles have low ionization density. Then, gamma rays and X-rays. It is electromagnetic wave, which is photons. Gamma rays and X-rays have low ionization density or high penetrating power. Last, for the neutron beams, it made of neutrons and it uncharged particles. Neutron beams have high ionization
Penetrating
density.
power of radiation. Each type of radiation has a different ability to penetrate materials. The material is said to have absorbed the radiation. The energy of the 3 radiations is absorbed by the material through which the radiation passes. The amount of energy which is absorbed depends on the type of radiation and the type of the absorbing material. The range of the alpha radiation is an absorbing material is less than that of beta or gamma. The alpha radiation transfers more energy to an absorber than beta or gamma radiation. Alpha radiation is absorbed by the thickness of the skin or by a few centimeters of air. Beta radiation is more penetrating than alpha radiation. It can pass through the skin, but it is absorbed by a few centimeters of body tissue or a few millimeters of aluminium. Gamma radiation is the most penetrating of the 3 radiations. It can easily penetrate body tissue. It requires several centimeters of lead or about 1 meter of concrete to absorb it.